Well friends, we will discuss here force acting on a current carrying wire when it is placed in a uniform magnetic field. Nothing but we will derive F is equal to QVB. How this derivation came. Okay, watch this. We will discuss about force acting on a current carrying conductor. Force acting on a conductor when it is placed in a magnetic field. Let us suppose there exists a magnetic field like this. There exists a magnetic field like this. We are asked to calculate, we are supposed to calculate force acting on this, force acting on a charge when this charge is placed on a conductor. Force acting on a charge, when it is placed in a magnetic field. We will discuss about this and we will obtain an equation which in short. Very easily one can get what is the force acting on this current carrying charge. Let us suppose this entire is a magnetic field with a magnetic field induction of B. Okay. Then let us suppose a charge Q is moving in this direction. Let us suppose a charge Q moving in this direction towards the field. Field is like this and the charge is moving with this in this direction with a velocity v. Then the net force acting on this charge Q with respect to the magnetic field can be calculated by using the force called, this force is called as Laplace force, or we will call this force as Lorentz force. This force is called as Laplace force or Lorentz force. Why? Because Lorentz is the first person to think in this era, and he derived perfectly what is the force acting on a charge when the charge is placed in a magnetic field. Let us suppose a charge Q is moving in this direction. When the charge is placed in a magnetic field, that means a charge, we pretty know that a charge always flows. Let us suppose when the charge is flowing means it has some velocity v. Then the net force acting on this current carrying conductor or current carrying charge Q is nothing but a product of its charge Q and its velocity v. Why? Because always a charge moves with velocity v, and as it is placed in a magnetic field, the magnetic field can induces some force on this charge. Henceforth, the net force acting on this charge Q can be calculated as the product of QVB. I think it is clear now. Why F is equal to QVB means? F is equal to QVB is a product of the charge moving with the velocity v in a magnetic field B. Then net forcing acting on the charge according to Laplace or according to Lorentz, this force F is equal to QVB. Let us suppose if this charge is moving parallel, charge is moving here, one can see that charge is moving perpendicular to the magnetic field. Magnetic field is in this direction and the charge is moving in this direction. Magnetic field is in this direction below and the charge is moving in this direction. Then both are perpendicular here. Let us suppose when the magnetic field is in this direction, say downwards, and the charge also moving in this direction, downwards, then the net force acting on this will be 0. Why? Because there is no angle subtended between the direction of the charge, that is velocity of the charge, and the magnetic field. F is equal to QVB. Here V is drift velocity, we will call. According to Lorentz, the velocity V is drift velocity. So one can attribute it that when a current carrying wire or when a current carrying charge placed in a uniform magnetic field, when a current carrying charge is moving in a uniform magnetic field, then the charge experience a force. Which is equal to product of its net charge, its velocity, and the magnetic field induction B. Okay. So this is the idea. By this one can calculate F is equal to QVB. Again, when there exists some angle between this, from this only we will calculate further F is equal to ILB sin theta. That's also, let me make it clear, because many of our friends will be having a particular confusion, or they may face a difficulty in deriving this f is equal to ILB sin theta also. Why? Because this only makes us to proceed towards the functioning of what you call, there is one of the famous branch of physics called as magnetothermodynamics, which tells us about the functioning of motor. The current carrying wire, the force experienced by a charge or a current carrying wire when it is placed in a magnetic field, which very much related to the motor, very much related to the functioning of motor, okay. Henceforth, let me make it clear. The force experienced by a charge when it is placed in a magnetic field is F is equal to QVB. This is clear to us. Let us suppose F is equal to QVB, that is known to us. QVB when it is makes an angle, it is sin theta. When it makes an angle, sin theta. Here the velocity is, we came to know that here the velocity is drift velocity. The velocity per unit time, the velocity of the charge per unit time taken as T is equal to L by V. We know that velocity V is equal to d by t, or we will discuss here V is equal to, this distance here is nothing but length of the conductor, V is equal to L by T we will write. So in terms of V, instead of V we will write L by T here, instead of T we will write L by T here. F is equal to, by considering the definition of velocity, we will write V is equal to L by T. Why? Because it is nothing but length of the conductor here, and in a unit time T, what is the velocity of the charge? It is nothing but it is Q. Instead of V, let me write V is equal to L by T, B sin theta. Then F will be rewritten as F is equal to, let me take T here, Q by T into Q by capital T into capital or small, whatever it is, L B sin theta. And we pretty known from the definition of the current that is nothing but Q by T is nothing but rate of change of current, rate of change of charge flow only current. Henceforth, this equation can be rewritten as F is equal to ILB sin theta. When sin 0 is 0, that is the case of when two fields were parallel, that is when the charge is parallel to the magnetic field, when the charge is flowing or when the current is flowing parallel to the magnetic field, sin 0 will be 0, that is equal to sin ILB sin 0, that entire terms will be written as 0. Why? Because sin 0 is 0, ILB into 0 is equal to totally 0, that is no net force acting on the charge when the charge is placed parallel to the uniform magnetic field, parallel to the field, net force acting is 0. Let us suppose when the object is placed perpendicular to the, when the charge is placed perpendicular to the magnetic field, then the net force acting F is equal to ILB, as it is perpendicular, sin theta is 0, since theta is equal to 90 degrees. Then we pretty know that F is equal to ILB sin 90 is 1. Then F is equal to ILB. By taking this, we will calculate net force acting. This net force acting only leads to different directionalities that can be explained in my next video. By assuming that Fleming's right hand rule, we will calculate the direction. In which current is passing and in which magnetic field induction will be there, in which the force acting will be there. This leads to the direction of the motion. I think it is clear. F is equal to QVB. It is nothing but, this force is nothing but Laplace force or Lorentz force. Do watch this video, show to your wards, show to your schools. Let me clear off this concept F is equal to QVB. How it came? Initially it is called as Lorentz force or Laplace force. Do watch this and subscribe my channel Ansari's video lessons. Thank you one and all for watching this.